Hello everyone, welcome to a new lecture series on Theory of Computation. So let's understand what do we mean by TOC. So Theory of Computation basically means it's a branch of computer science that deals with how problems can be described mathematically and solved by computers, what kinds of problems can be solved and the limits of what computers can do. So what do we mean by basically this is, so TOC tells us that how problems are solved by any machines using an algorithm and how efficiently that problem can be solved. So let's first understand what do we mean by this computation. So computation, as the name suggests, means any task that can be performed by a computer or any machine, right? Now, these computations that are performed by computer or any machine, they are used to represent various mathematical models. So how efficiently a problem can be solved on this model using an algorithm is in TOC. So basically, we will mathematically model our computer or any kind of machine and we will study the theory about it. Right? So in the theory, we will learn that what are the capabilities of this machine, what are the advantages, what are the disadvantages, so on and so forth, without going into the hardware details of the machine. Right? So we have in TOC basic building blocks on which the entire subject of TOC is based. So they are, the first is symbol, the second is alphabet, the third is a string, and the fourth is the language. So these are the basic structural foundation of the TOC subject on which our entire subject is based, right? Now let's understand this theory of computation with the help of a real life example, right? Imagine you own a coffee shop and customers come and place different types of orders, like they can place an order of a cold coffee, or they can place an order of an espresso, or they can place an order of a cappuccino, and so on and so forth. Now, there are certain rules in how a system works. The first is that you have a fixed menu. So this can be treated as like a set of valid strings in a language. So when we say that we have a fixed menu in a coffee shop, in terms of TOC, this can be treated like there are certain valid strings in our language, right? And only certain combinations of coffee are allowed. Like if I place an order of something that is not there in my fixed menu, then I cannot place an order of that kind of coffee. So the second rule says that you have a process to prepare each order, right? So this can be termed as the algorithm or the computation that we just talked about. Right? So if someone asks for a coffee, let's say latte with 2 sugars. So there will be a step-by-step recipe that you have to follow to produce this correct coffee, right? So this can be treated as the algorithm or the computation that we are talking about to process or the strings or in our language. The third is that you have a finite number of employees, machines and time. So what do we mean by this is, so this is like the finite resources in our computational model. So later, as we process in this subject, we learn about different kinds of mathematical models that we are talking about. So we learn about what do you mean by finite automata. This is one kind of mathematical model. Then we learn about another kind of mathematical model, which is push down automata. Then we learn about another kind of mathematical model, which are Turing machines. So these are the different kinds of mathematical models that we are talking about. So the third rule says that you have a finite number of employees, machines and time. So this can be treated as the finite resources in our computational model. The fourth rule says that you have only handle certain orders. We can handle only certain types of orders. Now what do we mean by this is, now if a customer, let's say, asks for a coffee, let's say triple layer mocha, right? Now this kind of coffee is not mentioned in our menu, but the customer tries to place an order about this kind of coffee. So your system might not know how to process this kind of order since it is not mentioned in your menu, right? So just like some problems are undecidable in TOC, similarly there are certain types of orders that cannot be handled in your coffee shop. So this is exactly what we'll study in TOC. So basically TOC is nothing but designing the blueprint for your coffee shops in which we have to decide what orders are possible, how to process those orders, how we are processing those orders with the help of certain algorithms, and understanding the limits of what your shop, or we can say our machine, can do, right? So in TOC we will basically try to answer three kinds of questions. The first say that what problems can be solved, The second question that we are trying to solve over here is how efficiently we can solve them. And the third problem that we are trying to identify over here is that what problems are impossible to solve. So these are the three kinds of questions which we are trying to address in theory of computation. And for all these answering such kind of questions, the basic building blocks that we will be using is what do we mean by alphabet, symbol, string, and language. So on this our entire TOC subject will be based. So see you in the next video, and we'll start with the what do we mean by the basic building blocks, and we'll try to solve some questions on it. If you like this video, then do like and share this video and subscribe my channel.